Welcome to my channel, and I'm back with you once again with another video of Explain 11. Today I'm going to give you a tutorial of the 737-800 NG series. This is a new plane by the Level Up team. It's by Threshold, and honestly speaking, it's a nice, superb plane. Obviously, if you are flying the Zevo 737, you will be enjoying Explain 11 a lot. And if you install the 737-800 NG, you will enjoy more than the Zevo. I've enjoyed it because obviously the interior is different, and the flying experience is also great. This is a new version, and obviously improvements are coming up. So if there is anything missing, hopefully it will be fixed in the coming few versions. But till now, everything is good with this plane. I have posted a link in the comments, in the description, not in the comments. And you can just follow that link in the description and to find out the link and the way to install the Boeing 737-800. And interestingly, once you install the 737 NG series, you also get the 600, 700, and 800 and 900. So this video, I will be covering the 737-800 NG, as I've been flying the 737-800 by Zevo. That's why I will be doing this. Weather, I've kept it as clear, and the time of day is early morning. It's 8 o'clock, and I will be starting my flight from Allama Iqbal International Airport. This is a very short route from Lahore to Islamabad, roughly a 40-45 minutes flight. So I'm using this route a lot for my videos because it's easy to do a short flight rather than going for a 1 hour or 2 hours of flight. So I will be starting this flight from one of the terminals, and I will be flying out from 36 right. And why I'm starting from any of the terminals is this, that obviously it's a tutorial, so I will be telling you how to start the plane from the cold and dark state. First of all, let's customize it and just see if this is unchecked. Start with engines running, so we don't need this. Right now I haven't installed any liveries for this plane, so this is the default livery that comes with this plane, and I think it's very decent, very nice, and I just enjoying using this one. Maybe in the coming future I will switch to another livery. So let's get into the cockpit and start this video and tell you how to do a flight with this plane. So here we are inside the Boeing 737-800 NG new generation, and it's lovely. The cockpit is really nice, and the view is really nice, and all the PFDs and the ECAM and the ND is amazing, and plus the tab is also different than the the Zevo tab. Okay, so first of all, let's just jump out of the plane and have a look at the plane from outside, and you can see that it's amazing. It's by Threshold, as it's written on the livery, and it's known as the Level Up 737 NG Series 800. It's an amazing plane, and trust me, if you try it, you will also enjoy flying this plane. The next video I will be doing for the 900 series, but it's really good so far. So let's jump inside the plane, and let's begin with this video. First of all, there are a few things that we have to adjust in the settings. Number one, as you can see it on the tab, there are two pages. So go on to the next page, and over here you will see configure and customize. Just click this option. First of all, go into display and go into system, and heads up display for the captain. Just switch it on, and you will see the heads up display will be here. Number one. Number two, just go over there to hardware, and for the nose wheel axis, set it to yaw, because it makes it easy to control the plane during the taxi. The nose wheel doesn't turn really well during the taxi, and the tiller is not used if this is on. I haven't tried the roll of VIA, but I found a fix for this, that if it is set to yaw, it will be easy to control the plane while taxiing. It will be easy to turn. That's it. And one last thing is to basically change the units. So go to general configuration, and instead of pounds, use kgs, because I'm more comfortable using the kgs. But if you want to use pounds, you can do it. And the barometric units, I'm just leaving them in because we can change it in the plane. and that's it. The rest of the settings, I'm not touching them. They're as is, the way they came with this simulator. Okay. Now, a short introduction to the cockpit. This is the overhead panel if you're new to the flight simulator, because every time when I make these videos, I just keep this thing in mind that, you know, beginners will also be watching this video. And I'm also a beginner, not an expert. That's why I just try to focus on the beginner level rather than going for expertise, because obviously I'm not that expert and there are many things which I obviously skip just to make things simple, but it's totally up to you to which complexity level you want to take this flight simulator to. Okay, so first of all, just giving you a basic thing if you are a beginner. Obviously, if you are flying this Level Up 737, I assume that you will be at a certain level of expertise. But still, there is something important that I want to tell you, a basic thing. Because initially when I started learning the flight simulator, the challenge that I faced was this, that most of the people who were making videos, they were actually going through just the starter procedure like this, turn on the batteries, do this and do this and do this. So it took me a lot of time to understand that why we are doing it. So in my video, I will also try to elaborate the reason for doing these steps. So the plane initially starts on the battery that is inside the plane, just to switch on the major components in the plane so that you can interact with the systems. And then there is a ground power unit, which is an external power unit, and it is attached to the plane, which is over here. And once you switch on to the ground power, all the electrical systems and air conditioning and everything is running on the ground power before the pushback. So before you start the pushback, you obviously have to disconnect from the GPU. That's why you turn on the APU of the plane, that is the auxiliary power unit. And after the pushback, the plane is running on the APU. And once you switch on the engines, or the engines are up and running, then you disconnect the APU, and then all the power to the plane is provided by the engines. And that's it. This is the pedestal. So we will be interacting with lots of things over here. And I've got a startup checklist. It's also here in this over here. If you go and see, you will see this checklist. So even if you want to follow this checklist, you can do it. But right now, I have my own checklist, which I will be using for this video. But you can download and install checklists. There are many other options available on the internet. But if you want to follow this checklist, it will work fine for you. So first of all, we have to switch on the battery, which is over here in the overhead panel. So just switch on the battery. And that's it. You will see all the systems coming to life once you do this. Oops. Okay. Now you can see there's some life in the plane. Now the procedure is basically, right now you can see that the ground power unit is available, and if you switch this option on, the plane will be running on the ground power unit. But I'll just tell you a trick that you can also call for the ground power from the tab. So if you go to ground services and you see GPU connect, and now the GPU is connected, and you can switch on the ground power. Now the plane is on the ground power, and you can see all the displays coming to life. The PFT over here on the left side, the navigation display, the ECAM, and everything. One more thing you can also check is, if you go over here on the overhead panel, you will see AC volts and DC volts, and you can check. So let's say if I move this to battery, and you can change to battery bus or different options. And plus, if you switch this option to ground power, right now it was on standby power, 15 volts, and you can also go to the ground power, and you can check this. Okay. Now this is one of the checks that you can do to see whether the plane is getting the right amount of voltage to actually function. Now disengage this master caution option. Make sure right now the hydraulic pumps are off, which are here, as you can see it on your screens. So you can we'll be switching on the hydraulic pumps later in this video, but right now just hydraulic pumps have to be in the off state, and the fuel pumps, which are here on the overhead panel. This is these two switches are for the central fuel pump, for the central tank, for the left, and for the right one. So they are also off. Now, if you are flying this plane in the night, obviously you'll be needing some lighting in the cockpit. So the lighting controls are over here. This is the brightness for the pedestal. You can just increase or decrease it. This is the floodlight. Right now it's morning, daylight. You cannot see it, but if you maximize the flood brightness, you will see just light over here. Okay, now behind this yoke there are more options for the lighting. Let me just yes, now so you can see you can increase or decrease the brightness for the main panel, and you can just adjust all the brightness that you want. And over here there is a control for the overhead panel, as you can see. And this is for the circuit breakers, which is at the back. So there is a spotlight, I think, for the circuit breakers, and this is the dome light. Okay. So that's an introduction of the lights. That's it. And then there are two more controls that you have to look for is the cabin utility and the IFE pass. They should be on. Check this. Emergency lights armed and covered. And that's it, one of the checks. This is basically the emergency exit lights in the plane. Okay, now another thing that you have to do is this: you have to set this position strobe to steady, which will tell the ground staff that you are in the process of starting up the plane. So that's why this is an indicator which has to be switched on. Now it's time to calculate the payload and the fuel and everything, and then we will begin with the flight planning and stuff. So let's first of all go to Simbrief, because Simbrief is the best right now, the tool available over the internet to make a flight plan and fly your planes accordingly. So here I am at simbrief.com. You have to make your login. It's free of cost, and once done, you can easily use it. It's actually by Navigraph. I have a Navigraph subscription, and my ARAC cycle is up to date. If you want to have a subscription, it's good because it's updated, and this is one thing which is necessary if you are flying Explain 11, because your ARAC cycle for the plane and for the for the Simbrief should be updated. Now the departure airport is OPLA, and the arrival airport is OPIS, which is the cow code for the Islamabad International Airport, and I will select OPST, which is Sialkot Airport. It's almost in the middle of Islamabad and Lahore. Sialkot Airport is selected. Airframe type is Boeing 737-800. You will see 700, and then over here 800. Let's select the cruise profile. I will be selecting 20. Now, cruise profile is actually a cost index which airlines use to determine the speed for the autopilot. The smaller the number, the higher the speed, the more fuel is burned by the plane. The bigger the number, lower the speed or lesser the speed, and less fuel is burned. So right now, if I'm setting it 20, it means this is a smaller number, so it will not be a fuel efficient flight. But if it's 40 or 50 or 60, it will be a very fuel efficient flight. So different airlines use the cost index as per their own settings. But for my flight simulation, I use 20 as the cost index. And for Airbus, while I'm flying the flight factor Airbus A320 or the fly-by-wire A320 Neo, I'm using 15 as a cruise profile. No need to enter this information. Departure runway will be 36 right from Lahore. Arrival will be at 28 right Islamabad. Extra fuel I'm not carrying. Altitude will be 25,000 because it's a very short flight. Soon after the top of cruise at 25,000, I think within just like 5 to 10 minutes, the top of descent comes. So that's why if you're trying to climb to 35 or 38,000 feet in this route, it's not possible. That's why I've kept it at 25,000. Passengers, I will set it to auto. Zero fuel weight, it's automatic. and that's it. And just make sure that the units over here are kg, because in the tab you have selected kgs. But if in the tab you have selected pounds, then switch to pounds. Otherwise, use these units. Now, down below, you will see the flight plan. I will be using, because you've got options, 1, 2, 3 and 4 options. You can select any of these. So I'm using this one because I've already tried it. I went into the FMC of the Boeing 787 and 737 plus in the MCDU of Airbus A320 and 330. This is a nice route and it works. But you can check different options if you want. But for this route, I'm using this option. So if you're making your own flight plan, obviously you will have your different preferences. Now once done, let's generate the flight plan, which will give us all the details of the fuel and everything, which we will be using to enter into the FMC of the plane. So over here, this is the operational flight plan, some basic information. This is the cost index, the distance, the air distance, and plus the average wind, and the ISA deviation of the temperature from the standard atmospheric pressure, and fuel burnt per hour is 2,966. It is calculated itself. Zero fuel bias, and you can see all the information over here. And this is the route, OPLA to OPIS. I will be telling you later how to do this. But first of all, we have to see that what will be the zero fuel weight of the plane. Zero fuel weight actually means the weight of the plane with the passengers and with the cargo, minus the fuel. Because fuel is like 5,379, so the plane knows what is the fuel, just wants to know the zero fuel weight. So every plane without the cargo and without the passengers has a zero fuel weight. You simply have to find the difference and enter into the tab. This is what I will show you how to do it. So we have to keep this thing in mind, that we have a number 60878. Now coming back to the plane, I'll just go back to the main page, and I will go to fuel weight and balance, and I will go to payload. So right now the zero fuel weight of the plane is 43,104 kgs. This is minus the fuel, and the zero fuel weight of the plane minus the passengers and everything. So I have to set the payload. So right now in zone 1 I will have maximum passengers, that are 16, 36 in zone 2, zone 3 also 36. You can see the maximum passengers that can sit in different zones. So I will say 36, and over here also 36. And you can see the plane was moving as the passengers were boarding the plane. Okay. So right now the plane's weight is 13,920. If I go back and I go to the payload, you will see it's 57,024. And as seen in the in the operational flight plan, we should be 60,878. If I subtract 57,024 from 60,878, let's see what number we get. And it is 3,854. So this is the additional weight that we have to adjust over here. If I put 3,854 over here, will it work? Yes, because it's more than the forward. Let's try entering. 2,000 and 1,854 over here. 1,854. So I've actually divided the 3,854 into two sections, in forward, cargo for 2,000 and over here. And that's it. If you go back, you will see 6878, that's 60,878. If I check the flight plan, it is also 60878. So this is now fixed. Now we have to adjust the fuel, that is 5,379. So 5,379, simply click this option and 5,379. Enter, and that's it. So now the takeoff weight is 66030 and all the information is here. and that's it. So zero fuel weight and zero fuel weight center of gravity, it's all calculated by the tab. Now go back and you can call for the fuel truck. In the Zebo mode, if you call for the fuel truck from the tab, you can hear the communication from the fuel truck. Right now I think it's not available in Level Up, but still you can see it over here on the upper ECAM, that the fuel is getting adjusted, the center tank is getting emptied, and 3900 over here. So we'll have some fuel in the left and right tanks and no fuel in the center tank. That's it. Now just head towards the overhead panel, and let's see whether the recirculation fans are on or not. And you can see they are switched on, the recirculation fan. So it's on the on state, it's off, and now it's auto or in the on state. Okay, pack lights left and right, sorry, not the lights, pack left and right pack should be set to auto. This is basically for the air conditioning and everything, so it's set to auto. And just make sure that the autopilot is off, and its disengage button is up. Otherwise, if you disengage the autopilot, it drops down. So it's up, and all the options in the autopilot are off. Speed brake is off. Check. And now some basic test for the engine fire. First of all, go over here onto the pedestal and move this the switch over here, test to the left side, and you will see fault and APU DET inop coming up. So this is check. Now this is the engine fire test. So all the lights should light up, and you should hear this error. Then there is this cargo fire test. That's it. So there are so many tests over here which you can check. This is for the APU. Okay. Now if you go over here in the after overhead panel at the back, you will see some more tests over here. This is for the stall warning test. If you press this, you will hear the stall warning, number 1 and number 2. Mark your speed. If your speed is getting high or slow, you should hear these errors. So this is all fine. Plus if you want to conduct some tests for the light, you can do it right now. And the light, if you switch this option on in the upward position, you will see all the lights up and blinking, just to show that there is no issue in the displays, and all the lights are on. You can check this, and plus there are certain errors also. You can check this for the FMC and for the auto throttle and stuff. Okay, you can check this. So these are the basic checks that you can do. Still, if you follow, as I told you before, if you're following some checklist, you can do the checklist on your own. Now moving to the startup procedures. First of all, we have to switch on the GPS navigation, and we have to set this iris to the nav over here. So these are two switches over here. Just switch them to nav. That's it. And display select over here, select it to heading. Now you will see 7. It means it will take 7 minutes for the plane to align itself with the given position. Now it's 6 minutes to get the GPS coordinates and everything. Crew oxygen should be 11 psi, which is good. And now it's time to configure the flight management computer. So now this is initially when you do it, obviously you find it a bit difficult, but trust me, if you know the logic behind setting the FMC, it becomes very difficult. So I will be focusing on the logic and the reason why we are doing this, and I will tell you each and everything step by step. So hopefully this will be helpful for you. First of all, go to FMC and check the ARAC cycle. It is active. I have an ARAC cycle updated from December 30th to Jan 26, year 2022. 2022. I'm saying it for the first time. It's been like, how much? 19 days? So 2022. Okay, now we have to go to the position initialization page. So simply press this. And over here you will see reference airport, which is OPLA. So you have to enter the OPLA. And you enter this and it will pick up the GPS coordinates for the OPLA. And the gate is 13 if you remember, but it's not an important information if you don't even enter this. It doesn't make a difference. Set iris position, you will see all these empty with a box. It means it's important to give this information. So while on this page, you will see that there is a option coming as 1 by 3. So it means with this page, there are 2 more other pages. And in order to navigate between the pages, you have to select previous and next page. So if I click next page, I will see some GPS coordinates left and right. I will pick up this one. You can pick up the right as well. Just go back, click this button, the soft key on the right side, the 4th one, and you will see the GPS coordinates are now there. Now the system of the plane knows what is the GPS position of the plane. And you can see it's almost accurate to the one selected with the airport. Okay, so this is the position initialization which was required. Now we will go to route, and you can see the moment we move to this page, OPLA appeared. Simply click this option and OPLA will come here. Now the destination, you can see it in boxes. It means it's important to give this information, so OPIS. And just click this number and it will come here. Button, the first one, and then AA123. This is the flight number that I use, initials of my name, Atif Ahmed 123. Company route, just ignore this. Runway is 36 right, 36 right from Lahore. And that's it. Now activate and execute. Okay, now this information is here. Now you will see another page 1 by 2. So we have to now set the route of the flight. That is, you have to go to the next page. Now here we are. So for this, now I have to go to Simbrief to get the route information, which we will be entering over here. So here I am at a Simbrief, and this is the operational flight plan as seen before. Now this is the route. I will just tell you basics if you are new to the flight planning and everything, and this will information. I'll just try to keep it simple, although there is also a very detailed flight planning video on my channel. There are 2 videos. One is I uploaded almost 3 years back, and another one is also there, which even tells you how to fix the discontinuity. So you can go and watch those videos. But for this tutorial, I'll just try to keep it very simple. There is some basic information in this flight plan. This is the departure and the arrival runways, and this is the flight path. In this flight path, there are 4 things. One is the SID, which is this. One is the star, which is this, and in between, it's airways and waypoints. SID is basically the standard instrument departure, which you used. It's basically a procedure to basically depart from a runway. So if I'm flying out from 36 right, there will be a certain procedure that the plane will follow to reach this waypoint, the first waypoint, Umugi. So OMUKI2D is actually a procedure which tells the plane the path or the route from the runway to this first waypoint. And this is the star. So before this runway, there is always a star, and it is basically an arrival procedure. So you have to follow a star in order to proceed towards a runway. And in between, it's airways and waypoints. Anything in alphanumeric value is an airway, and all alphabetical points are waypoints. So it means the first plane will take off from 36 right. It will follow a star, a SID, and for the departure. And using this departure procedure, the plane will go to this waypoint, OMUKI. From this waypoint, the plane will take the J220 airway to the waypoint Salna. And from here, DCT means direct to Sialkot. This is a VOR. It will fly to Sialkot VOR and then direct to Indek. And then from Indek, it will take a star, Indek 1A, to land at 28 right. So let's start entering this information. So right now, in this page, I am not selecting the SID and the star. It's for the departure and the arrival. I will be just focusing on this flight path. So OMUKI J220 Salna, and that's it. Let's go. So O M U K I. So this is the first waypoint. Then J, where it is, J220 to Salna. From here direct to SLT. So you can see the first viewer. This is the first one. I'll not be selecting the NDB, and this is viewer DME slate. So I'm not going to slate. Obviously, it's not in Pakistan. So I will be selecting the viewer DME Sialkot because I know it's a city between Pune and Islamabad. And then the last one is Indek. So I will fly directly to Indek, and that's it. It was really simple, and just press execute, and that's it. Now you will see a flight path is already entered over here, as you can see in the navigation display. If you move it to, if you come to this this panel and you see this option, if I select it to plan instead of map, right now map is selected. If I select it to map, and if I cycle through the flight plan, I will see it. So legs, I will go to this option and I will press step. So the first point is coming as Umuki, then to Salna, then to Sialkot, and then to Indek. So right now you cannot see airports. Why? Because we haven't entered the airport information. So let's go to departure and arrival, and for the departure I will select 36 right. It is already active, as we have already set it in the position initialization page. And after that there's OMUKI 2D, as I shown you before in the flight planning. So this is the SID, as you can see, SIDs, and that's it. So press execute, and that's it. Now we have to select the arrival, which will be ILS 28 right or left, anyone you can choose. I'm selecting ILS Y 28 right because we will be going for an ILS approach. And plus in the Indy 1A, in the Simbrief it says Indek 1A, but I'm selecting Indy 1A because it's like the same. At times there is always a disconnect. Sometimes there is a disconnect between the waypoints over here in the FMC and in the Simbrief, but just ignore it. Just try to find the right one. So in Indek 1A and Indy 1A, it's the same. So I'll select this one. Now it's asking for the transition. A transition you can ignore or you can select. But let me tell you how to select the transition. So right now you can see two transitions, Isdur and Kimul. If I come to this operation flight plan, where is the map? Yeah, here is the map. You can see that before OPIS there is a point Isdur. So it means this is my transition point from where I will be following the star. So Isdur is the point from where we will be following the star in D1A to land at 28 right. So I will select Isdur and just press execute. Flight planning is it's another art that you have to learn. So it takes a lot of practice. You have to create lots of flight plans in order to get a hands-on training, but I'm just trying to keep it simple for this video. So this is how you can enter the SID and the star and the transitions, and that's it. Transitions, if you're flying in Europe and Pakistan and Middle East, transitions are not that important, but if you're flying in US, then there are transitions. You can always refer to the airport charts to get the transition information. Now I will just check the flight route, is it good or not. So that's why I will go to the option legs, and over here now you will see the flight plan clearly. So now we are taking off. As you can see, we are taking off from this runway 36 right. Initially it was not coming. Now as we have selected a departure and arrival airport, that's why it started to come. So I will just press this option step, and it will just take me through all the waypoints. Indek, Punop, Isdur. Now you can see from Isdur there is a procedure for the landing, which is the star, and that's it. Now this is the runway. So it means the flight plan is good. Switch back to map, and that's it. So this was for the planning. So after the planning is done, let's go here. FMC, position initialization, route. Now this planning is done. Now I will go to performance initialization. Now the cruising altitude is flight level 250, that is 25,000. So I will select FL250. Okay, now cruise wind and ISA deviation. These are the two important things that we have to enter. Now I will tell you how to get the ISA deviation and press the wind at the cruising level. That is 25,000. So if you go to the operational flight plan, you will see over here there is some flight log information coming. What is the what are the waypoints and what is the top of cruise and then top of descent, and all this information is coming. Now if you see at the top of cruise, when you're cruising, the wind speed over here, it's given over here, it's 289/042, and the ISA deviation is right now 18. Sorry, P04, it's 4. So 289/042, it means that the wind is blowing from the direction of 289 degrees at the speed of 42 nautical miles. Nautical miles, knots. Okay, 289/042 and 04. 042, enter, and this is how you enter the cruise wind option, and ISA deviation is 404. I'll just enter it over here. It will pick up the temperature. For the gross weight and the center of gravity, just click it and it will pick automatically. And reserves, let's check for the reserves. So in the flight plan, you will see that we have this finers and alternate. You can see it's 2,643 tons. Sorry, kilo kgs, and or maybe 2.6. Not maybe. It's 2.6 tons. So simply come and enter 2.6 tons over here as the reserves, and the cost index is 20 as selected before, and that's it. Press execute. Now for the N1 limit it's actually the percentage of power given to the engines, the maximum power. So I'm selecting the maximum power. You can see 36,000 pounds thrust, and the climb profile is number 1. It means the plane will climb at almost full throttle, that is, as you can see, 98% of thrust. But if you want to go for a deaccelerated or derated climb, you can select any of these options. It's mainly for the fuel saving in the real life and just to have less and wear and tear of the engines. That's why they go for a derated takeoff, but in the simulation you don't have to worry about that. So you can just simply go with the maximum. Then for the takeoff flaps, I will be extending the flaps to 5 degrees. So 5 degrees, the ones I've selected it. It will select the V1, VR and V2. It's already selected. And center of gravity, if you click here, it will calculate the center of gravity, 24.2%, and trim is 5. Now, the takeoff performance is actually set just right before the pushback and before switching on the APU. But right now, for this video, I'm just setting it everything here because I'm just trying to do this video in blocks. I'm not trying to mix up the FMC setup with the startup procedures, because then there will be too much going back and forth to FMC and to different panels. So I'm just trying to keep it simple. Configure the tab, basic switch on procedures for the plane, and then FMC configuration, and then I will proceed further. But if you are following any checklist, obviously the steps will be different. Okay, now let's check over here. Is the fuel set? And you can see the fueling is now done. And we have fuel in the left and the right fuel tanks. Okay, now it's time to switch on the fuel pumps. So we have nothing in the center tank, so that's why just leave this. But for the left and for the right, just switch on. Now EFIS, that is the Electronic Flight Instrument System. But before moving here, we have to switch on the APU. Now it's time to basically time for the pushback and for the flight. That's why the APU takes some time. That's why we will be switching on the APU right now, because then we can switch to APU power and disconnect the ground power unit. So switch on the APU. First of all, switch it to on, and then press this button downwards and then leave it it will go to start position and then back to on. Right now, within some time, you will see this gauge moving. It will go to maximum, and then it will stabilize some point higher than 4, and this light will go bright. So then it will be time to switch to APU generators. But right now, I will wait for it. So before doing anything else, I will go to this panel, EFIS, that is Electronic Flight Instrument System, which is over here, and I will configure some basic settings over here. First of all, as discussed before, I will be switching this option to map, and then the range for the navigation display, I will keep it at 20, which is good for the flight. If you're doing a flight, it gives you a good view of the flight. Okay, so now this setting is done, and then I will wait, go and look at the APU. Now you can see the APU is now up, and plus this light is also bright, so it means we can switch on the APU generator, so that now the plane is on the APU, auxiliary power unit, and that's it. You can just hear it switching towards the APU generators, and then turn on the APU bleed, which is over here. The switch you can see, this is the APU bleed. Just switch it on, and just make sure that the engine bleeds are also on. So APU, and this is all on. And just to check whether we are getting the full voltage from the APU or not, just go over here into AC volts and change this option to APU generator, and you will see we are getting volts from the APU, so it means this is good. Now at this point you can close the doors, as I didn't open any doors or no passenger or cargo service, but you can just do it from the tab. If you go to the ground services, you will see the doors. You can close them and open the doors. That right now I'm not using this option, so it's good. Okay, so that's it. Now it's time to disengage or disconnect the GPU, and we will just proceed further from here. Now just get to the tab, and you can disconnect the GPU, and you will see the systems are up and running. There is no issue, because right now the plane is on the APU power. Now with this, I will go to the MCP, which is the mode control panel, which is this panel is the MCP, which is the mode control panel, and then we will make some adjustments over here. Now first of all, the speed, it has to be set for the autopilot. What is the speed? Which speed we should select over here? It is the V2. So I will go here and I'll show it to you on the screen, V2. Now this thing I skipped while setting up the takeoff performance. While setting up the takeoff performance, there are 3 speeds that you get: V1, VR, and V2. V1 is actually a speed at which you can, below the speed, you can, or up till this point, you can abort the takeoff, and you can still stop by the end of the runway. But if the speed is above this 136 knots, then obviously you have to either take off, or if you abort your takeoff, then it will be very difficult to stop the plane till the end of the runway, so it can be catastrophic. VR is the speed at which you rotate on the stick to lift the plane from the runway, and V2 is the speed at which the plane can comfortably fly on one engine. So your speed should be 147 knots. So over here the speed should be set to 147. This is your speed, and once the plane will achieve 147, I will, after the takeoff, I will set it to 250, which is the speed the plane should be at below 10,000 feet. It's a normal procedure. Okay, so this is the speed that we have set. The heading for the Lahore runway 36 right is 359. So I will just set the heading, because if after the takeoff I'm not selecting the LNAV option, which is for the navigation, I can also go with the heading select, and plane can fly towards this heading, but it will not be used. Altitude, let's set it to 25,000. And that's good. 25,000 is the altitude. That's set. Flight directors, that is displayed on the PFDs on the left and on the right side. Just switch on the flight directors, and you can see FD appearing over here. And then arm the auto throttle. This is necessary for the for the plane to set the speed, and plus LNAV and the VNAV. It should be switched on. LNAV is actually for the longitudinal navigation, and VNAV is for the vertical navigation. If you switch on the LNAV option on, the plane will follow the flight path. So this is to tell the autopilot just follow the flight path rather than going with the heading select. So it follows the flight path. And VNAV is actually for the speed and for the descent. So once this option is on, the autopilot will automatically adjust the plane's speed and plus the descent and the climb rate. So these are the two important things that you have to set. Okay, now some basic checkups. Generator bus transfer switch, it has to be covered. Let's go and find it. So this is bus transfer, this is covered. Hydraulic pumps, as I told you before, just it was off, but now we have to switch them on. So hydraulic pumps on. Anti-collision lights on, and isolation valve, it should be open. This is the isolation valve over here. You will see it's set to open. Altitude overhead panel check. Okay, so this is something really important to check. I'll just show you. The altitude we will be cruising at will be 25,000. And the landing altitude is 1750. It is for the Islamabad airport. How to get this information, I'll also tell you later how to set get this altitude information and the heading information for the runway. But just to close the topic right now, it is very important to set the altitude over here, as this altitude is for the cabin pressurization. So if it is not set properly, your pilot will black out. And trust me, it happened to me. During my initial flights, I just ignored this, and once the plane was at 25,000 feet, the pilot just faded. My display started to get dim, and I started to think, what is happening? Maybe my display or system has an issue. But eventually I knew that there is an issue. And I ignored this error. So just set this to auto and do this. Now coming back to the point that I've set the heading for the departure runway and for the altitude for the arrival, how I get this information. It's very simple to get this information. Go to this website skyvector.com, and over here you will see airports. And just click this option of airports. It's free of cost. You don't have to pay anything for this information, and you can get the information of any airport. And if I enter OPIS, you will see that for the Islamabad airport, the elevation is 1761 feet. So this information is here. If I go back to airports and if I select OPLA, you will see more information. I think for OPIS there's not so much information in the SkyVector, but for the OPIS there's so much information coming in. What is the radio frequency for the approach, for the ATIS, Lahore ground control and tower, and plus these are some VORs which are near the Lahore airport, and this is the VOR DME because it's got a box around it. Then you can see for different runways, 18 left and 36 right, and 18 right, 36 left, you will see the length of the runway in feet and meters, and plus the coordinates and the elevation and stuff. So as you can see, 360. This is how I know what is the direction of the runway. So you can easily get this information on SkyVector for zero cost. Okay, so now this is done. Make sure that the throttle is in the idle position, which is in the idle position. Packs off. Now it's time for the pushback. So before the pushback, I will just tell you that why do we need to set the packs to off, because right now it's all the power and all the air is required to start up the engines. That's why you have to switch off the air conditioning so that all the power is given for the engines. So that's why I will set left pack and right pack to off, so you can hear it just going down. Okay, now packs off, release the parking brakes, and I will now call for the pushback, because if the parking brake is engaged, you cannot call for the pushback. So I'm not using any plugin. I'm using just the built-in option, and I will try to taxi towards right, but I think it doesn't work in the default pushback tool for the Experience 11. So let's jump out of the plane, and let's see if I can see the push cart. I think it's here. So it's coming. Soon the pushback will start, and as soon as with the pushback, I will start the engines. Before starting the engines, I will just tell you one thing. If you go here, you will see an option over here, engine start. So it should be towards the right side, and the moment pushback will start, I will start the engines.
Here we go.
And the pushback has started. Let's wait for the pushback to end, because I don't want any mishap. In the Microsoft Flight Simulator, it stops automatically. In Experience 11, it doesn't. So you have to, or maybe it stops. I don't know. I'm just mixing up Microsoft Flight Simulator Experience 11 a lot. So it is good. See, it's not turning right. So I think there is some issue. Okay, just keep an eye on the, because we have to follow this line. So I will just stop the pushback, and that's it. And I will engage the parking brakes. And I will just turn left and start by taxi once it's time to taxi. Okay, now just make sure that this switch, as I told you before, is set towards right. Then this is the engine start button, control switch. Just move it to ground, and then come over here, and you have to actually fuel control switch over here for the engine 2 to up state. Okay. Oh no, not now. Sorry, we have to wait actually for this figure to show 25 or more than 20. Then we can start the engine 2 for the this is actually the engine fuel control switch. So it starts the flow towards the engine of the fuel, and I think it should stabilize at 50. So now you can hear the engine 2 is running. So this is how you actually start up the plane. So engine 2 is up, and then we will go to this engine 1. Okay. So you can see it's stabilized at 58.2, and this switch also is set back to off. So it is good. Now this engine ground, wait for 20 to appear for N2. And now on, and that's it. It's morning. You can these are actually the lights for the landing, for the taxi. As it's daylight, we don't need these lights. Logo, I can maybe turn it on, but as dog you can see this switch is also set to off, so it means both the engines are now up and running. Now we have to move these switches to continuous 1 and 2. So now they are in the continuous mode, and engines generator switch, we have to turn them on. This is now the plane is on the engine power, and you can see the APU is off. So now as the APU is off, I can switch off the APU, and I can cut the APU bleed or set it to off. This is now off, and then packs to auto. Get back the air conditioning, as now the plane's engines are up and running. And over here, if you go back, window heat, switch it on, and probe on. Engine anti-ice or wing anti-ice, if required, you can switch it on, otherwise you can just leave it like this. And yaw damper, just switch this option on. Flaps set to 5 degrees, so it will be 1, 2, 3. You can set the flaps from here as well. I've configured them on my Logitech Extreme 3D Pro, so that's why I've just pressed the button 3 times to have flaps by 5 degrees. Auto brake, set it to RTO, which is the rejected takeoff, so in case if you decide to abort the takeoff, the plane will stop. And that's it. One last check which is required is to close the cockpit door, which is at the back, and just close it. Nice, just a nice sound, just like the actual one. Okay, now everything is good. All we have to now do is taxi this plane and fly it out of Lahore towards Islamabad, and that's it. So I hope we will enjoy this flight. Let's get the heads-up display. One of the best features in the 737. At times it just gets very difficult to get this heads-up display. I don't know what kind of views I'm just moving to. I've actually not configured them on the predetermined keys, as I get really confused which key to use. So I'm just using it like this. Or maybe I've seen many people using different options. You can switch on the yoke as well. You can see it over here. So now the heads-up display is here, which will show you altitude, vertical speed, and everything. Everything is now set. Parking brakes, I can just release the parking brakes, and then I can give some throttle to the plane in order to taxi and plus take this plane up in the air. So let's go. I've released the parking. No, sorry, I didn't release the parking brake. My bad. You can see it's a nice plane. The cockpit is really nice. The systems are good. Almost everything is working perfectly all right. And if you learn how to fly the 737 NG series, somebody is going really vertically up. You will be able to fly the 737, the default plane for X-Plane 11, and plus 747 also. So it will be easy for you. Now I'm at the runway 36 right, and just look at this mark over here on the screen on the ECAM. You will see this green mark. We have to keep the throttle up to this mark. We'll not give 100% throttle, because we are keeping it at a deaccelerated rate, as said before in the takeoff settings. Okay, so now here we are at the runway 36 right, ready to take off, and that's it. Everything is looking good so far, so there is nothing to be really worried about. Okay, so let's give throttle and take this plane towards Islamabad. Just keep an eye on over here on the PFD. You will see the VR speed, which is for the takeoff, for the rotation.
80 knots. Rotate. Positive right.
I think we just picked it up a bit early. Okay. Now gear up.
Gear up.
Positive rate of climb.
400.
it's very high rate of climb, 5,000. I think I should reduce it. Yes, the rate of climb was really high, so I'm just trying to adjust it. Actually, after the takeoff, the priority is to basically achieve the higher altitude. So that's why you have to keep this vertical speed really high, but this was too high. Now the thrust has also been reduced to 92%. Let's I'm just trying to manage it so that I can track the flaps. Now you can see the speed is increasing because I've controlled the vertical speed. And that's it. You can see the speed is increasing and increasing. Now let's track the flaps and let's engage the autopilot. Now the autopilot is engaged, and you will see the speed is increasing too much. Okay, this has also happened before as well. Let me just try this thing. This thing happened before as well. This thing has happened before during the takeoff. So you can switch off the VNAV and try with the speed, and then this thing is happening. I think maybe some error or something like this. The climb rate. Look at the climb rate because it's trying to compensate for the speed. So that's why the climb rate is really high, 6,300. Mostly people are coming and commenting on my side that at times my climb rate is really high. But honestly speaking, if you look at the way these autopilots are configured in this plane, it goes really high. And I've seen it also in the actual flights as well. So it happens like this. So even recently I made a video and it happened. So it's very normal to have a very high climb rate. If the speed is increasing and everything is good and the plane is not stalling, it's good. Okay, now you can see that after the takeoff I had some issue engaging the autopilot. I pressed this button, didn't work. I pressed the second button, and after setting the second button, the speed was not getting under control. So that's why this issue happened. But then I switched off the VNAV option. I switched to the speed, and then it got controlled, and then I went back to VNAV. I think it's an issue. Maybe it's solved within some time because it happens. Right now, the barometric pressure, we have to set it to standard. I did not include the barometric pressure in the initial startup, but during the descent, I will tell you how to set it and why this option is set. So if you just zoom out, you will see that the top of climb is coming over here, and this is the top of descent. Okay, so once the plane is climbing, I will just right now switch to the airport chart for Islamabad International Airport to see some basic information for approach, and I will tell you how to read the approach charts. So this is the Jepsen airport charts for the simulation. It's not to be used for the real life, it's only for the simulation. And if you have a Navigraph subscription, these charts are there in the Navigraph. But if you're not using Navigraph, you can download these charts from the internet. It's very simple. Just type in the account code for the airport, OPIS, and then space, and just type charts. So you get these charts and you can download them. Over here I have to find the approach plate for this OPIS, and I have to get some basic information. So if I keep on scrolling down, I will go to the 28 right approach plate. 10 right, 10 right, 28 left, 28 right. Let's see where it's 28 right. Okay. Now, so there is some basic information that you have to see. Over here in this diagram, you will see that if you're coming from Renix at this point, this is basically ILS or Z. I'm not actually using Z. I am using Y. But still, you can get this information from it. Okay. So if you're coming from ISDOR, because I was using ILS Y 28 right. This is what I selected in the plane. So the heading of the runway is 279 degrees. This is the one information you have to remember. The localizer frequency is 110.7 for the ILS. This is radio frequency. Final approach course 279 seen before. Glide slope to be caught at 3,000 feet. So while descending, I will descend from 25,000 to 3,000 feet so that I can catch the glide slope. This is the glide slope. It's actually an angle which plane takes in order to land at the runway at the right point. And then this is the decision height, which is 1,950. The elevation for Islamabad International Airport is 1750, 90 as I told you before. So this information we know. And the decision height is 1,950, almost 200 feet above the ground. This is the decision height at which you can just decide to just declare a missed approach or want to go around or if you want to turn back. So now as we have this information, we will see that how we can use it to our advantage and how to configure everything. First of all, I will set the heading to 279. If again, just like the takeoff, for the landing, you also have to set 279. So in case if you don't want to use LNAV, you can select heading select, and the autopilot will follow this heading. So first of all, turn this, change the heading to 279. Okay. Now over here, come to the pedestal. You will see 3 panels over here. One is for the radio communication with the tower and with the ground. Another one is for the navigation, and the third one is for the ADF. These are 2 for the navigation aids. I'm not using ADF, but we will be using nav. And nav aids, you will see that we have the option of entering the ILS frequency. Right now you can see the 110.70 is already selected. But if you want to select or enter 110.70, how you do it? Just simply move the bigger dial to 110 and then 0.7 the smaller dial, and that's it. So and press, if you press this button, this frequency will become active. Let me show you the co-pilot side. So 110.7, and if you click this, now this is the active frequency, and that's it. So all you have to do is this, enter the ILS frequency. Is basically ILS is a localizer, an instrument that generates radio communication in order for the plane to follow the runway. So if you want to catch the runway, you want to be perfectly aligned with the runway, you should have ILS frequency, and this is how it will work. ILS. Okay, so now ILS frequency is given. Decision height. Now, this is where we have to enter the minimums. The lowest point from where you can decide to turn around or abort your landing. So switch this minimums to baro, and over here, if I'll move this dial, you will see numbers changing, barometric, and I will set it to 1,950. So let's press left click, and this number will change 1,950, 1,311. I will not reset it. At times it gets difficult. So almost close. 1,950, and now the minimums are set. So before the landing, you will hear a voice saying minimums before the landing. Okay. Now this is good, and that's it. Now the auto brake, let's set it to maximum because after the landing we want to apply brakes, so the auto brakes are set to maximum. So this setting is also done. Let's go over here, and does it pick up the speed? No, it doesn't. Okay, so this is all good. Approach, you can see during the approach some settings. 40 Flaps, if I go with the full flap landing, the speed should be 141 knots. So I'll just copy it, and you will see it is copied, and I will paste it over here. Okay. So now the glide slope is on. We will see the glide slope, and that's it. This information is more than enough for the landing, and that's it. So this is how you basically program the plane for the ILS approach and landing. So it's very simple. So everything is looking good so far, and there is no issue. The last thing is the barometric pressure. We have to first of all check the barometric pressure at Islamabad airport, and then I will adjust the barometric pressure there. How to check the barometric pressure in Islamabad? It's very simple. In the Simbrief, if you go down below the operation flight plan, you will see arrival and departure. So if I select arrival, you can see the weather information from the METAR. And over here you will see the QNH for the barometric pressure is 1013. Temperature is 10 degrees, and the dew point is at 10 degrees. This is the information that you need. Scattered clouds at 4,000 feet, SCT scattered, 0404,000. And that's it. So you have to adjust this barometric pressure. And why do we use it? I'll just tell you. So first of all, 1013, I will switch the units to HPA instead of IN, and 1013. Now I will use this line. Now you can see this information is here, but right now it is at standard. For every airport there is a transition altitude. For Islamabad International Airport it's 15,000 feet. How do I know this information? It's there in the airport charts. Transition altitude is given, but you really don't have to worry about the transition altitude because as soon as the descent will start and the plane will cross the transition altitude picked up because of the flight plan, you will see this this thing blinking. So once it's blinking, you can always switch from standard to the given barometric pressure. The plane actually has got sensors outside the plane, on the body, and these sensors actually use the barometric pressure to gauge the altitude of the plane to determine. And right now you actually adjust the barometric pressure in order to adjust the altimeter. So that's why this barometric pressure is adjusted in the plane, and it's done during the takeoff and during the landing. So during the takeoff I ignored it because it's not really a very important unit during the takeoff. Obviously if you have to match your altitude with the ATC and stuff, if you want to get into the nitty-gritties and into the details, then it's an important thing. But during the landing obviously you have to set it, because then the plane will gauge the altitude correctly. And as right now I was not using the real weather, so that's why it's not even applicable. I had clear skies, so maybe this number is different than the one showed in the operation flight plan, because the operation flight plan is picking up the real world information. Now the stop of descent is coming. I will descend to 3,000 feet because this is the point where I want to catch the glide slope. I will keep it at 3,700. Because if you look at the point, you will actually, once it's clear, you will see the altitudes for different waypoints over here. So this is the point where we have to be. So I will just wait for this point to reach. Let's zoom in a bit on the navigation display, and you will see that the top of descent is coming. And after this point the plane should start to descend. As you can see, this number is decreasing. As soon as this number reaches 0, the plane will start to descend, and you can see it is now descending. Now the descent has started automatically thanks to the autopilot and to the VNAV option. Now the plane will adjust the speed and the vertical speed accordingly in order to be at 3,700 feet at a good point. Below 10,000 feet the speed will reduce to 250 knots, but above 25,000 will remain at 280 according to the cost index or the that we have entered in the FMC during the flight plan. So brakes I've already set to max, and the heading is given. Altitude, glide slope set, and the ILS frequency is given. So these are the settings that you need, and that's it. Now you can see it on the screens that over here in the primary flight display, the standard has changed. So it's coming in a box with a yellowish mustard color. I don't know. I'm very bad with the colors. So if I press this option, now the atmospheric pressure is changed from standard to the given one. That's 1013 that I selected. So everything is good, looking good so far. Right now, plane is crossing 16,000 feet and descending to 3,700. If I zoom in a bit, you will see different information coming in. Over here at this point, you should be above 6,000 feet, not below 6,000 feet. And over here, this is a deceleration point, so this is where the plane speed will reduce. I will also take the flaps. These are the different flap settings. So at 250 knots, you can have 1 degree of flaps, 2 degrees, or 5 degrees of flaps, up to 5 degrees of flap at the speed of 250 knots. At 210 knots, you can have 10 degrees of flap, and so on and so forth. So these are the flap settings. As we are going for the full flap landing, the speed should be 140, which is easy to control. So I will start extending the flaps after the plane is below 10,000 feet, and the speed will start to reduce. We will hear some errors because right now the speed is getting adjusted by the autopilot, so that's why we will ignore it, but eventually the speed will slow down. So after the below 10,000 feet, I will go with the 3 degrees of flaps. 3 notches rather, up to 5 degrees. As you can see, the plane is crossing the 10,000 feet mark. That's why the speed is reducing. I will still keep the speed. I will not extend the flaps so far. Just keep it like this. We'll wait for some time because it's already late night. I have to get up for my office, so I don't want to prolong this video, and I just want to finish it as soon as possible. I'm a bit hurry because it's really late night. So because now as the basics have been covered in this video, so it's only to land the plane because everything is there. We only have to follow some procedures for the ILS, and you will see it's very easy. It's not that difficult. So let's check the ILS frequency. 110.70 entered properly, and the acceleration point is also coming. The speed is set to 240. Yes, it is good. At this point, the speed will reduce further. So ISDO, the plane should be at 6,000 or more than this, cannot be below than this altitude. But I always try to keep this thing in mind, that the plane is always at this altitude, because then it's easy to catch the glide slope, because you don't want to come high. Because if you're at a higher altitude, it's obviously very difficult to catch the glide slope. Your descent rate will increase in order to catch the glide slope, due to which the speed will increase and it will be very difficult to control. So that's why while doing flight simulations, I always try to be at that altitude given for the waypoints, because then it's easy. You don't want to come really high and hot while approaching a runway. To be safe. Okay. So it was a smooth flight, and as you have seen, that it's very easy to fly this plane. Obviously, it takes some time, practice. It also took me 4 or 5 days to practice and to make the flight plan. Once you get the hands on, you have your checklist, you have the understanding, then it will be easy for you to do everything. So it's not that difficult. So I think we are safe. 7,200, 7,200, and still some distance to cover. Slightly up, but still. We are at a good level. And as soon as we are near the runway, you will also start to see the ILS information, as it has started to come now. You can see 2 diamonds, one over here on the right side and one below. So once you are properly lined with the runway, this diamond will move into the center, And once you are just right at the intercepting point of the glide slope, this diamond will come here. And change the information. You can just experience, you can just what you can say, experiment with it. As the deacceleration point is coming, that's why the plane is leveling off slightly a bit, and plus this point the plane should be at 6,000, which is there. So it will further start the descent. You can see from top of descent from 6,000 feet, it's coming here. So nothing to be really worried about. Just keep an eye on the navigation display while you're doing the flight. So after this point, the plane will again start to descend towards the runway to 3,700 feet that we have entered before to intercept the glide slope. If this diamond is below this line, it means we are coming high. We are at a higher altitude. As it is above this line, so it means we are at a good safe altitude and we will be able to catch the glide slope at the right point. Now you will see as we are static at 6,000 feet and nearing the runway, that's why this diamond is coming here. But as soon as we'll start the descent after this point, the autopilot will start it, and this diamond will start to move up again. And there will be a point when this diamond will be just in the middle, and then over there I will just hit the approach button, and then everything will be carried out by the autopilot. So that's simple. The ILS approach is simple. It's not that difficult. So nothing to be worried about. Just wait. After this point, the plane will start to descend, and then this diamond will start to move up. Right now you can also activate the approach mode, and the plane will start to automatically follow the glide slope, but right now it's too early. You can see now the plane has further reduced the speed, so we can just go with 4 notches. That is 10 degrees of flaps, and the speed will be set at 180 knots. Now the plane is descending at a high rate because now we have the flaps, and the flaps provide an extra lift to the plane at the lower speed, and plus it also provides the drag. So that's why the speed is under control, and the autopilot is descending at a high rate. You can see the diamond has started to move up. Flight level 3,700, we should be at 3,700 or above, not below. But as I told you before, 3,700 is a safe altitude.
2,500.
So 2,500 feet to go. I will right now just wait a little bit. 2,280. The plane is leveling off at 3,700, and then I will activate the approach mode once the diamond is in the middle, and it's coming, and hey. So the moment I've activated the approach mode, the descent will again start, and the plane will start to follow the glide slope. And you can see the distance measuring equipment, ILS DME, it's 6 nautical miles away from the runway. At this point, I can lower the gears, and I can further extend the flaps full as we're going for
Gears
a full
down,
flap landing.
3
I'll
greens.
reduce the speed to 140. I'll keep it at 142 to be on the safe side, and you can see the plane is now following the glide slope, adjusting the vertical speed in such a manner that this diamond always remains in the middle. So right now the speed is set to 142 knots. The moment I activated the approach mode, you can see the LNAV and VNAV disappeared. Now you have to set the speed manually, which I have done it. Heading is 279, and ahead you can see runway 28 left over here and right. So everything is good. Now the speed is at 140. Full flaps. The brakes are set to maximum. So everything is good. What else do we need? A safe landing. I'm very bad at landings, I'm telling you before. So if you find any mishap, please don't mention it in the comments. So it is good. 840. Go. Just 100 feet above the ground, I will disengage the autopilot and I will just try to land it manually. I will disengage the autopilot and the auto throttle so that I can adjust the throttle. You can see the autopilot is automatically adjusting the speed and the altitude automatically.
100. 30, 20.
This was a bad choice. Anyhow, this was really bad. I wish you were not here in this plane. At the end, the autopilot just screwed up with a few things. Oh, this was a disaster at all the levels. Anyhow, this was not a tutorial related to landing, but I have to disengage it. It was too hard. It was really hard, honestly speaking. Okay, thank you very much for staying with me. You can practice it with the autopilot. I think I should have disengaged the autopilot slightly before. I've been doing it before. It never happened like this. Anyhow, at the end, there were very drastic changes in the autopilot. Was just like going up and down. Thank you very much for staying with me. If you've got any questions, do ask me in the comment section, and any positive feedback is always welcome on my channel. I always love to receive some positive feedback. And if you have got any information to share with me, do let me know, and you just let me know how was your experience with this Level Up 737NG. That's it for this video. Hope to see you soon. Have a nice day.